Okay, this video is going to walk you through real quick some ideas of what might be causing you trouble on this problem. First, make sure you type this equation in your calculator and hit graph. It's important that you have your window set to the same dimensions that you see here. So if you want to go to your window button, type in a y maximum of 8, a y minimum of -1, an x minimum of -1, and a x maximum of 6. Then hit enter. You should see enough of the graph doing what it's doing at these places that you see in the graph. Now you'll notice that this graph here goes on forever into infinity for all four directions for the domain and the range. However, we are restricting the domain between the coordinates or the x values of 2.5 and 5.5. That's why the graph stops here or starts here and stops over here. Next, finding zeros and x-intercepts. Look at the graph. Where does this graph touch in the x-axis? You can see it's touching over here at 5, 0. So you could try to put 5, 0 in here, but it'd be better to go to the table just to verify that 5, 0 is the actual answer. So go to your table button by pressing second graph and verify that 5, 0 is the right answer. In this case it is, so make sure you're using parentheses 5, 0. The y-intercept, you'll see this graph does not touch the y-axis. It does on your calculator screen, but not on here. So therefore you would say that this has no y-intercept, or type in the word none that you see right here. Maximum, looking for the highest value this graph gets to, which in this case it looks like 3, 8, and in this case it does. If you go to the table, verify that 3, 8 is the highest point, and type in the coordinate 3, 8. There are some times you may have to in these problems. You have to find the maximum value by pressing second trace, option 3 or 4, finding maximums and minimums with the calculator option, and then left bound, right bound, and find that highest point. You'll see that in the directions of our video that was prior to this. And last of all, minimum value, this coordinate right here is at 5, 0, the lowest point. Again, using your calculator table, you can verify that for your minimum value. Last of all, you're looking for intervals of increase or decrease. The interval of increase is when the graph is going up. You always start from the left and work your way across the graph to the right. So when you start on the left here, the graph does go up between these 2 points. Now this interval of increase is only the x values of these values on the graph. So this is at 2.5, and you can know that by the domain where it starts, 2.5. And it continues going up until you get to this point right here. At this point right here, you're going to have the highest point at 3. You'll never equal these boundary points. So from 2.5, 2.5, less than x, which is then less than 3. That's how you're going to type in your first interval of increase. Now, the only reason I'm typing this is because there's 2 answers. Also, make sure you're not typing extra spaces. This also, then the graph goes down from the 3 on the x value here at 3, and from 3 all the way to 5, this graph is going down. But it does go back up again from 5 to 5.5. So then we would want to say our interval of increase is going to go from 5 is less than x, which is less than 5.5. Whoops. And that's how you're going to type in your interval of increase for this graph that's going up twice within the graph. And last of all, your interval of decrease is when the graph is going down. It goes down from this coordinate right here down to this coordinate right here. Now we're only using the x values again. So you're going to have this from 3 up to 5 as in this graph is decreasing. So we say 3 is less than x, which is less than 5. Hopefully this information gives you a better idea of what to do with your graph and how to investigate it in the future. Good luck.